You will not see any facility in the US that makes the product we use in concrete pumping, period, than what you see here. No one.
This is different. We're not in Canada anymore.
You're not in Canada.
And we know this guy.
If you come out, if you head out this way, I'll find you and I'll meet you and we'll go do a tour.
I'm not gonna lie, a couple months ago when I saw Jeff pop up in a video from the facility in Texas, there was a little bit of a green man on my shoulder. A little green man.
Yeah, you did sound
There's a little jelly. So he came all the way to Port Washington, Wisconsin?
Yep. And you had to one up Jeff by coming to our plant.
Yes.
I think that was the most important thing. You one up Jeff. In your competitive nature, you now are ahead.
Always priority one. So we were at the ConForms facility, manufacturing facility. This is the mothership. Is that fair to say? The mothership?
Yeah, this is the facility.
So we're going to look at everything ConForm. Twin wall pipe, heat treated pipe.
And in Warstein, Germany, you know, Esser produces makes all of our twin wall pipe and then sends it to us. So, and then we finish it here.
So we're going to get the full tour today. We're going to do some fun stuff. We're going to test some equipment in the I want to call it the blow up chamber. Can I call it that?
Yeah.
We're going to blow some stuff up, or at least try to. The burst tank. All right. Well, here we go. We'll roll in. So we're here. We're here at the heat treater, right?
Right.
This is where the magic happens.
Right.
So what's the process here, Mike? In a nutshell.
So that pipe just got done. It's going to roll out of the way. These are due to be done. This is going to be our Ultra 3 or our Guardian boom pipe. Our Super 7 gauge, right? Yep. Super 7 gauge. So one of these pipes is gonna drop on here. This block is an electromagnetic. It runs a magnetic field. The magnetic field is so strong, it's gonna heat this pipe up super red hot, super fast as it passes through. This is the cooling lance there, the water jet. You can see the little like mushroom head on the top there. The water comes out and sprays backwards. So as it comes through that coil, it's gonna be red hot, hit that water lance, and you're gonna see it turn, you know, back to its normal, you know, from cherry red to its regular color, you know, very quickly. This way we get a good consistent heat around the perimeter, and it doesn't, you know, it's not just heated from the bottom. So we get a better, more consistent heat treat here. And I'm gonna put my earplugs back in because this is gonna be loud, but you're gonna see that pipe is being fed right now through here, through there. We've probably about 15 seconds. You can see that's how hot that is to start. Now, that water jet's gonna start any second now. You can see it blasting out the end. See how fast it's cooling the pipe? And that's how we do heat treating in our facility. Goes into a tank or a cooler, it cools it, and we keep reusing it, recycling that water until we can. Watch this go through here. That little tiny wheel leaves a mark on the pipe when we heat treat all pipe. So we know when it went through the facility and the date. So you can see, it's hard to see these little slash marks. This is a code, but if we follow it over here, there's a CF and the numbers here. This is the code and the date of when it went through our facility, so that if for some reason we have, you know, people are like, oh my gosh, Mike, your pipe is blowing. I can come over when I come visit you if we have a problem. I take the paint off this in a circle, find that mark, and then I follow it to that code. Then I can call our different guys at the facility and say, this is the heat treat code on this. You know, are we seeing more problems or more issues?
So is anybody else hardening with a magnet like this that you know of? Or is it mostly flame?
This is more expensive to do than what most people do. They do this with a flame. So they heat from one spot on the bottom, heat the pipe, and then it rotates really slow through it. We found that heat treating all around the perimeter gives us a more consistent heat. So when we cool it, it stays the same all the way around. When we heat from the bottom, they do get small degrees of temperature change as it's rotating through, so the pipe is not heated evenly and not cooled the same way. It cools at different rates. So what that does is it creates the hardness bands that we've seen in the pipe, where we get the, it looks like there's a wave to it, or the rings. We saw that on some of your pipe, you know, in your yard.
Yes.
Your boom pipe.
Yeah, I recall that, yes.
Same thing, you know, we're done with this pipe. As soon as it rolls out of there, this thing's gonna roll it up, drop it on this rack.
So how cool is it now after going through the water jet?
Well, you can touch it in a second.
So that's the pipe we just made.
Yeah, it was just heat treated. Now, this pipe, if we were using non-heat treated pipe, it's the same pipe. We make it all with the same chemistry. We just don't heat treat it, right?
So what is this on a hardness scale? Like a 63 57 HRC?
Somewhere around there.
And before heat treating, where would it fall in at?
Probably 30-ish.
So it essentially doubles the hardness of the pipe.
Yeah. And it more than doubles the life of the product. That's why, you know, when we're looking at stuff, I'll often say to guys, do your people take care of their reducers? Do they lose it all the time? If the answer is no, 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 then we should be buying heat treated reducers. We should be buying heat treated elbows, like on the back of trailer pumps and stuff. You know, it'll last a lot longer. The pressure rating's higher. It's stronger.
Right.
All around, it's a better product. Same thing with the pipe. Heat treated pipe is not double the cost, but it'll more than double the life of, you know, the pipe that you're using.
Okay. And also I know for like a high-rise application, it increases the pressure, the maximum pressure rating as well.
So
correct?
like this pipe, non-heat treated, is rated about 190 bar. If it's heat treated, it's 375 bar.
Wow.
Where no pump goes to that pressure rating.
Right. So it's more so the metric ends on a boom pump application that are limiting the pressure rather than the pipeline body. Is that fair to say?
That is exactly right. So if we use the same pipe and we put heavy duty ends on it, it has a much higher pressure rating than the metric ends. I want to say it's around 150, 180, you know, for 7-gauge pipe that's Ultra 3 with heavy duty ends. But if we put a metric end on it, the highest we can go is 100 bar.
And is that strictly because the heavy duty end has a taller lip?
Correct.
It is.
We
okay.
get more engagement on the clamp as it goes over the edge. If you look at them, you can see the heavy duty edge is slightly taller. There's more clamp engagement. The metric ends don't allow for the clamp engagement.
Okay, okay. We'll probably talk more about that when we go to the burst tank later on.
Oh yeah.
And blow some stuff up.
Yeah.
We're gonna have some fun.
Yeah.
You don't want to miss that. That's gonna be the best part of the video, I promise.
Those are 5 to 4 reducers.
They're 5 to 4.
Yep.
And they weld them like this so you can send them to the heat treater?
Yep. So these are heat processed in the heat treater over at the Grafton facility. It's got more rollers to support all this. And so we stitch weld all the reducers back together to process them through our heat treater, as our heat treater does a better job to heat treat than we used to send them out for carburization.
Ah, so even the reducers are heat treated in-house now.
Oh yeah. So, and as you can see just over there real quick, our mining pipe, we do a lot of different things that people don't even realize we do. But that's through our mining.
What is that, like a 24-inch diameter pipe?
20 inch.
20 inch.
Diameter.
And we can heat treat that the same way,
Yep.
the same quick speed, everything.
Yep.
We can do all of that in different sizes. We go up to what size,
Just
Mike?
turn the power up and turn the water up.
Yeah. And what size can we go to?
This machine has the capacity to do 42-inch diameter. Currently, I think the largest I've run is 30-inch.
30 inches.
It's like a lifetime supply of reducers for me right here. That's what I'm looking at. I'm in heaven right now. Wow.
For you, baby.
We'll get with you shortly.
Oh, so what is this, like a non-usable then?
Yeah, this is a reducer that, you know, I can see it's tapered. For some reason, they're not real happy with it. It was at the end of a run, or it got damaged or something, so they just scrap it.
Oh, okay.
All this is scrap. We do a lot of different things in the facility. Like I said, some of this, you can tell it's at least 1/2 inch wall, but some of that's made, you know, for reducers, you know, where we expand the metal, you know, by forcing it hydraulically with a press. So we just do so much here. As you can see, we're not Walmart or, you know, some of the other guys that are just buying the stuff from China, Korea, Turkey, and just have it on the shelf. We're making it, you know, or we have people make stuff and we finish it. You know, there's so much we do in this facility. One of the things you're going to leave here today with is, wow, I didn't know you guys did that much.
It's about as made in the USA as it gets, pretty much, right?
Pretty
These
much.
days?
You will not see any facility in the US that makes the product we use in concrete pumping, period, than what you see here. No one. They may do little stuff in their facilities, do a little welding or cutting, but the scale that you see here is not done in the US. We are it. Pushes its way and makes reducers.
So the hydraulic press that makes reducers.
Yeah. We basically lubricate that in this wedge, get pushed in here and opens that end up, and this is how we make, you know, a lot of our reducers. You have to constantly lubricate, you know, the metal as it's being pushed on there so that it doesn't, you know, get wedged in there. So again, this is just a 4-inch pipe, blank, a little different thickness than what we're used to. He sets it in place. As you can see, the mandrel is all greased up, you know, to be forcing in there. And he'll grease the inside of this so that it doesn't get stuck anywhere.
I do pipes in here 120 inches long.
So yeah, he'll do 10-foot reducers, or 10-foot, you know, 10-foot and 3-foot long, or 3-meter long reducers in here. And he'll have to stop it every 4 to 6 inches. Otherwise, like I said, it'll get stuck on there. As you can see, we're starting to develop the bell on the end here.
Different sizes?
Yeah, they come different sizes.
So where's the one for the short 4 to 3? Okay, so where having this 3 to 2 ConForms reducer puts me is, it puts me just one short 4-inch to 3-inch reducer off the back end away from being fully conformed out. I do have a regular length 36-inch conform 4 to 3 reducer, but for what we do, I really like this little shorty. So if I could score a lucrative sponsorship deal, Mike, and land one of these guys, we're fully conformed off the back end. We got the elbow, we got the pipes, we got the 3 to 2. I have a long 4 to 3, just need a short 4 to 3 and we're good. And look at this, all conformed clamps too. Mwah, it's a beautiful thing. I'm not leaving here today without one.
Your suitcase, I'll make sure you go home with it.
Well, it's only gonna be 14 inches long, so you might regret saying that.
I have a little bit of pull here, maybe.
You know a guy. You know a guy who knows a guy.
I know a guy. So this is one of the things, you know, when we're inspecting stuff and the painters, everybody's supposed to be tasked to catch everything. No, but they notice that they don't like the porosity in this weld.
Ah, yeah.
And so somebody tagged this and it came out. You know, so we do have, you know, we have a bunch of QC people, you know, that's their job, is to watch stuff like this and try to, you know, we try to correct stuff as it goes. Higher volume moving parts, they'll kind of set a crate here so that they can just pack them up.
Look at that. So 2 inch, 2.5, 3, 4.
And these are all adjustable.
This is like
that, 5? Yeah.
5 inch.
5 inch. So, like I said, these things move so much that they'll put them here.
It's just like heaven. Oh, I'm in a toy store, man. Oh, swing gates. Are those CCI?
They are. So we had a huge run on these this year. We sent a bunch to a big company in Australia, and it blew up our utilization, you know, because guys just don't wear out the 7 to 6s. They, you know, they can last a couple boom kits. So
a couple.
Yeah.
Our 58 meter pump, I'm not even, no lie, we got close to half a million meters through one of those, and it was still heavy.
Yeah. So the thing is that since they don't get changed, you know, when we have a big, you know, not every boom kit's going to have a 7 to 6 on it. So when we have a big run of them, we have data. We sell 200 a year, whatever it is. And then when that number goes to 300, or for some reason our monthly usage goes way up, well, we're behind. Because, why would we sell 100 more or 200 more in a year?
Right.
There's no reason for it. We have lots of data to average over, the 50 years that we've been in, over 50 years we've been in business. So
you get one customer that orders an extra 50 in a year.
It gets us in trouble.
Right.
Because we can't, we can never anticipate the spike in demand on stuff. Like, I had a project where they were talking like they would need over a mile of quarter wall heat treated pipe. Well, that's over 500 sticks of pipe. Well, we've got the material here, and we had a bunch of heat treated and processed, but it's pretty much going to eat up everything that we have in inventory.
Yeah.
So anybody that orders it after I put in that order was behind. We had to heat treat it, we had to paint it, we had to weld it, we had to do all those things. So we try to stay ahead of those things with stuff that we know is in high demand and it gets ordered in large quantities, but it blows us up on occasion.
So if you're going to order 100 swing gates, give Mike a bit of notice.
Yeah, give me a little notice, please. There's a lot that goes in there because of its funky shape. The liner that goes in it isn't as precision as what we can do with elbows and twin wall pipe. So the voids are filled in with an epoxy or a different product, a grout or slurry, so that it locks it in place to hold it there. Because we can't take that funky shape, put it in there, and have it fit perfectly. Like our twin wall pipe, there's only so many facilities in the world, and I think there's only 2 or 3 tops that can make twin wall pipe with the liner and the shell so precision that it fits in there where there's not a lot of air gap between the 2 layers. The more the air gap is in there, if it plugs, it shatters the pipe all the way around. And that's the biggest problem we find with Chinese imports and stuff. If you plug, it shatters the pipe.
Right.
You look at them and it's got cracks everywhere because it's brittle and it just breaks it everywhere.
So I'm hoping today we can find a little a scrap of twin wall or an elbow or something and take a hammer to it and display exactly what we're talking about.
Oh, I'm sure we'll find something.
Okay, so we've got tan primer and white primer, and the difference is?
So we made this change a while ago, and I started pushing it, and everybody else, they saw what we were doing. So white product, this is a pipe bend, 4-inch, 90 degree, 9-inch centerline radius, heavy duty ends, heat treated, and it's white. That way you can tell when you see it, clear as day. So if we look at this tan product, reducer, 5-inch to 4-inch, 36 inches long, metric end, D for heavy duty, no H, so it's not heat treated.
And this one here, 4-inch to 3-inch, heavy duty
ends, heat treated.
Heat treated.
Yeah, it's a huge change in what we do, because when we're looking at stuff like this is a customer order packed up, we can see there's a lot of tan reducers, so they're not heat treated, and we see a couple white ones.
Right.
We're, especially on high rises and big projects, do I need an elbow like this because I'm in trouble? We can put that in there, but we don't want it in there long, perhaps. So we see the color change, and if I'm walking the project and I go, Scott, why is there a tan part in here? It should all be white.
Yeah.
Oh, we had to change it out because somebody hit it with a forklift, and we had to put this in there. We got another one coming. Okay. At least we know now, what happened.
So now it's very visually apparent now.
Right.
So the reducers with the eyelets, the loops on them, do those need to be welded on before hardening?
They're welded on afterwards.
They are, okay.
Some of the smaller ones will actually build this whole thing if it's little, because you saw our heat treater.
Yes.
So unless it's hard to send something through this size. So we have a lot of product, like this elbow probably goes through our induction bender, which we'll show sometime, or you might have seen it in a video, coming up, where we make this and it's heat treated as it goes. This, if this was a smaller reducer, we weld it all up and we send it to somebody that puts it in an oven that heats it up to the right temperature and dunks it in a saltwater bath.
Oh, okay.
Because we can't heat treat, that stuff. We don't have an oven here.
Okay, makes sense. So So if those are welded on after, is it insignificant enough, the welds are small enough, it doesn't affect the heat treat to any noticeable
as long
degree?
as you're not putting the heat to it and really burning.
It's not like welding an end on where you're applying heat for a long duration of time.
we're
Okay.
not
So that's why they're able to put them on after the fact with the smaller stuff. Okay.
Yeah.
Makes sense. Makes sense.
Here's some 7-6s. This is single wall, not painted. You know, Mike, I need this right away. Well, it's not painted because we're gonna send some that are lime green. We're gonna send some that are orange, white, blue, all these different colors. So we don't paint anything that has to do with blue pipe.
Are these hardened steel now?
Yes, those are forged steel.
Forged steel.
This is actually X-rayed and magnaflux before it leaves.
Okay.
So if they see air bubbles in this, it goes to the garbage, and we start
So this
again.
is a nice in between just a regular cast swing elbow and the heavy high dollar CCI.
I guarantee this will outlast most imported, if not all imported 7-6s with CCI lining. U.S. steel, like I said, the biggest problem we had with cast products back in the day is they were made and there was air bubbles in the steel, and you wouldn't know there's an air bubble in here because it looks pretty on the outside.
Right.
You look inside, it's pretty, but we wear a little bit of the inside out. Now the air bubble's showing and back ends were exploding.
Okay.
This is not cast, it's forged, so it's a different process.
Oh, so it's the whole thing is a forged piece. Interesting.
The ends are welded on, as you can see the welds, but the majority of that is cast in place.
So just
This is cast. You can see from the outside it's a little coarser. The exterior, it's a little more bumpy, and, you know.
and cast is just molten metal poured into a casting.
Oh, yeah.
Forged, it's placed under pressure. Essentially,
Yeah.
Essentially.
Simplified, yes.
and it minimizes air bubbles, denser material. I'm assuming, right?
Yeah, and about 10 years ago, we had a rash of back ends exploding, not ours, but other people's that are being imported into the U.S. And that's when the whole back end cover started thing about 10 years ago.
Yes.
We're not backing up to your pump. Well, that's because of the porosity in the casting. The countries that are doing it have more manpower. They don't want to invest in equipment. So they were manually kind of filling these molds up, and they weren't doing a good job. They looked pretty, but they weren't doing a good job.
Isn't that funny that not much of this back end regulation didn't really come into place until the same time period as that influx of offshore copycat components?
I would say
Interesting.
so, because
What a coincidence.
the volume of all
Right?
that stuff went way up. Right?
Yeah. Yeah, I don't think it's a coincidence.
A drying oven, and we'll see that during our tour. But this is the boom kit, you know, all painted. He's got all the labeling and safety stickers there. So after it's done and sitting on the rack, he can come through and mark it. This is a swing extended elbow.
Now that looks like a 4.4 inch.
No, it's 5 inch.
Is it 5?
Yeah.
265M, so that's CCI, right?
Yep. And then the last 5 numbers is a differentiator for just what it is.
So that is that the tip elbow they use on the 39 meter? They have an extended tangent on the 39s, I believe, right?
And they put them in the turrets.
And a turret as well. Okay.
They run them through hollow pins as well. You know, on a swing, they'll put this through the hollow pin. So this elbow is pretty frequent in a swing.
That looks like a puts elbow there, the extended tangent.
That, I want to say, is a swing bend as well. It's probably a 25 degree with extensions.
How much easier would your life be if all the manufacturers just went to standardized bends?
Oh my God. It would,
Right?
it would change the world because we've got so many, there's so many funky bends.
Yeah. It would bring the costs way down.
Oh yeah, because
Right?
we could build the stuff at a higher volume. We may have a dozen of these on the shelf, but if I look at our inventory of common 90s, we probably have hundreds.
Yeah.
Because each boom kit takes 8 to 15.
Right.
So, you know, we've got to stock all the funky bends. We got to stock this funky bend.
So
We
once again,
also-
if you wonder why they're quite expensive, that's the reason.
I mean, this is a little pipe on the back of a swing that goes between the 7-6 and the 6-inch elbow. So like I said, this is telling me it's for one job, and it's marked here on the sticker, you know, when they scan this, you know, so they know, you know, what job it's for.
Oh, it'll say what customer it's for.
All of our safety labels, somebody did something stupid at one point, so we had to create a label. So everything gets stickered here. Advantage, endurance, whatever, our safety stickers.
Oh, I like those.
Yeah. So
I wasn't gonna ask, but I kind of wanted some. Thank you.
So we've got a super cool label machine. I don't see it here somewhere. But
You know my favorite labels? That guy. That guy needs a name.
We've got Buster Plugs. We need a name for that guy. So our painting is done in this facility. You can see it's in part of the larger building. So we are permitted to use like low VOC, low chemical, xylene, and all that other stuff. It's done inside, and then they can run it through. We've got a couple dryers here, you know, to cure the paint. Our painting quality has improved. It's not automotive quality. If you call Alliance or Heatmeister or Schwang and they paint something for you, they have a full dedicated paint shop, you know, with the guys wearing respirators and two-part, you know, mixes and stuff. We're now doing paint a little differently with another company that's giving us a better finish with direct to metal. So it's done here and then it moves out. So it's one of those things that we just can't, you know, spray Imron paint and give you that automotive quality shine that you get from a new car. Again, you can see all this stuff is sitting here waiting to be painted, you know, all raw metal where they'll prep it. They'll roll that part down inside the paint booth.
Yeah.
Spray the stuff, tan, white, or some special color, and do his thing for you. You don't realize how much we do until you're here.
There's definitely a lot going on.
We've got a cycle test going right now.
It's like a hyperbaric chamber.
Yeah, to protect us. And so like this is an example, we are constantly working on improving the quality and also making our processes more efficient. So we've been working with Lincoln Electric on some of our weld processes. And so they made some recommendations on some things that we could change to make it easier for the operators, for more consistency in the welding process. But before we just start flying it out to the field, we do a significant amount of testing on how does it affect the heat treat, how is the weld quality, the pressure like, and a lot of those different things. So that's what's going on in here now.
So is that machine cycling it? Is that what that sound is?
Similar
Okay.
to a pump. Similar to your pump, because it's not a constant pressure load.
Right.
It's the cyclical loading that the pump is putting out.
Okay.
So we cycle it at your pump max pressure, 85 bar, and then at the end we'll see if we can blow it up and we'll do some heat testing.
So yeah, what we're doing in here, Mike, what are we doing in here? Where are we?
This is one of the facilities that we have on property that tests product. As Matt said, there's a lot of things that we do that you guys don't see. You know, if we can make the weld smaller, introduce less heat, he's the guy that's looking at stuff, as well as Carl. Those guys are looking at all this different stuff to see if we can do stuff faster, better, use less weld, you know, less heat into the product. This is where we test stuff. Right now you're cycle testing. So right now it's going 1200 bar, let's up the pressure, 1200 bar, so we can see how many cycles. And we can run this, and when it explodes, it'll tell us how many times it's cycled, or we can set it for a certain set. We can also blow things up here to see if it's meeting the pressure requirements. As part of CPMA, which I talk about all the time, when we have a pressure rating on something, it has to meet that pressure. So we do it mathematically, and then we put it in here, and they want to see us blow the stuff up to make sure.
This is like a piece of twin wall pipe, or it might be like a 487, a single wall boom pipe. And so that's what I was just testing. The hose will be the fun one, that's the one we can blow up. So I'll hook that up now, because this one's got another 2,500 cycles to go. So this will go for another couple hours, just cycling.
Oh wow, okay.
And so I'll take this one off, hook that up, and then I started getting some clamps set up for some of the products that you guys had as well.
So this is all, it's all hydraulic cylinders creating water pressure.
Yes, water pressure,
okay.
correct.
So like you said, this is boom pipe. you know, we are testing this boomer dead.
Boom. 487.
Right.
Yep.
So this is our Guardian boom pipe, as you might know, Ultra 3. And again, how many cycles are you going to do through this?
This was 2,500 so far. We'll go up to 5,000 cycles.
Okay, so
that's a pass.
5,000 times of pressuring it to the maximum pressure of your pump, 1,233, and we let the pressure go. We do that 5,000 up to 5,000 times as a pass.
And then we'll try and burst it, and then we'll do all the heat testing, which is destructive after the fact.
So after we cycle test it, like I said, we blow it up, and then we take it and make sure the well's open.
Yep.
What are we blowing up first?
Now, this is one of our hose.
Our hose.
Our hose.
We're gonna blow a hose up?
So
Yeah.
Scott's gonna put his earplugs in because it gets quite loud.
But then I can't hear myself talk, and I like to hear myself talk.
Yeah.
They're really going in.
You'll see soon enough why we.
There we go, okay.
All right, so you want to stand over here, you can watch the pressure gauges for that.
I'll make sure we're not going to
So
start.
what can I expect when it blows up? Am I
I'm giving you those coordinates.
And so similar, we do a modified cycle test with hose just to kind of stretch out the rubber in the hose body, make sure that we're not just kind of bursting it right away.
So that's our pressure. We just went to 1,000 PSI.
Yep.
What is this hose rated for?
So this is a steel bond, which I believe is our Advantage hose. So it's either 85 bar or 100 bar. I'd have to look at the label on it.
Which will be between 12 and 1,500 PSI.
Correct, and we burst 2 to 1, so it'll go to 2,500 PSI. We'll do a couple at 1,500 and then we'll blow it up.
Pretty nervous right now. I'm not even.
Well, it's the if factor, like when is it gonna blow? We don't know.
It's like the jack in the box.
Yeah. And now, because it'll go over 3,000 PSI probably, I shut this off so we don't destroy our gauge. And here we go. Get this back off. So that went to 3,400 PSI.
Wow.
So a 2 to 1 rating is 2,500. Even if it was 100 bar, 2 to 1 is 2,900.
See, we're above a 2 to 1 safety factor. We just don't label it as such.
Right.
Now let's look and see what happens.
What did we get?
Oh yeah.
And so that's a pass. So if an end came off as an example, that's a fail. We don't care what pressure it is. If the end comes off, it fails.
So that's a fabric hose and not wire braided?
So that's the steel wire.
Oh, it is a wire, okay.
Yep. Yeah, so that's our steel bond Advantage hose. And so
Which is a little higher pressure rating than a fabric?
It's 100 instead of 85 bar.
Okay.
yeah.
So our wire hoses are rated higher.
So the wire is not that much higher. Does it fatigue better generally, or is it?
It's the reinforcing.
Yeah,
Is-
it's probably a thinner hose. There might be some other factors to it.
So this one, we have 2 different metal reinforced hoses, wire and cable. This one's wire, it's woven with wire. Our Trelleborg hoses, which actually would flow up much higher in pressure, are made with cable. And the cable, you know, is multiple wires woven together to create the reinforcing. So it's completely different.
Okay.
So when people say, I don't want something to fail here, I'm like, then you want to buy our N2 hose. It's the best hose on the planet. Period.
Okay.
N2 hose, nobody makes a better hose than the Trelleborg N2.
So this is the one that we welded in-house using our equipment and our procedure that we've been using for.
We didn't blow up the 2.5-inch clamp, or did we check out?
No, we're gonna do the 2.5 next.
Okay.
So this will be the last one, but this is our in-house. This is just to test our welding for our high-rise makeup
Tony
pipes.
welded us, so we've already got money on it. We're thinking 800 PSI.
Oh, that's cold. No, I think it'll hold. But then were you saying that we're gonna inspect the welds
Then we're
too?
gonna section it.
Yeah.
We'll section it.
Yeah, so that'll be good. Tony will just be like dying to be able to see the test data on his
Oh,
weld.
he's very
He
excited
even
to see the
sent us
results.
how much gas he was using and what rod and everything.
Conditions that were welded in, vertical and horizontal.
Yes, yeah, we got gas percentages and the whole deal.
Yeah, he sent everything.
Everything.
You got bolts in there?
Yep. Yeah, everything's in here from the hose.
So this thing is going to pressure right up. I mean, it looks pretty robust.
I would expect this to. Yeah, the welds look good. I don't see anything. I don't see any defects from my untrained eye. And so that's where John would say a lot of these welds, you're not going to just break the weld until you do more cyclic loading, and you actually, a lot of the welds, regardless of what kind or who's welding it, you're going to have little like cracks at the back of the weld, and until you cyclically load it and work that crack through the weld, you're not going to fail it.
So the lab's going to tell us a lot more about these welds than the pressure testing probably will.
Yeah.
Today.
This is the Tony pipe.
The Tony pipe.
Getting ready to be pressured and stuff. The welds are pretty good. Tony did a good job there. He labeled everything the way we should. We're gonna burp it to make sure there's no air in it so we're not compressing air. So as soon as we get that done, then we're gonna run it up a ways. We're not gonna take it to maximum, we're just gonna test it.
Like I said, if it goes over 5,000, I'll probably stop it.
Yeah.
Just around my comfort level with the machine. But the gasket may leak, we'll see what it does. So there's 2,000, 3,000, 4,000. So there's 6,500 PSI. Well,
So right now, good job.
Good job, Tony.
Yeah, good job, Tony.
It's pretty tough to get those kind of answers out of Mike, those kinds of reactions. The critic. Hey, we just drew blood from a stone.
Well, I throw shots at you when you're not in the video, and so we
I know.
taken any
I
shots
hear about
at
them
Muddy
all.
Feet, or but since Tony's not here, we can take a shot at him every now and then.
And so yeah, this section in the edge will have a lot more to tell you about the quality of the weld, but it obviously wasn't bad because it made it to 6,500.
So that's the next stop is we're gonna, so what do you cut the weld open and kind of look at?
Yeah, they'll cut off the pipe and then kind of cut a cross section so you can see the weld from the side.
Okay.
And then we use a nitol chemical and etch where it'll actually show you where the weld is in the pipe.
Exciting.
And so on like a twin wall pipe, those will typically burst anywhere from 3,000 to 4,000 where the pipe will actually just split.
Okay.
Because the pipe's only a couple millimeters thick. Whereas a single wall, like our 7-gauge even, and this, you just won't.
So we're gonna do all that next today. We'll get all the answers.
Yeah, so I'll take this
Exciting.
off, we can take it over to the inspection team.
Yeah, it's going to the lab.
To the lab.
Do you want one?
And so we just did a couple different ways that our standard process works. Basically, adherence of the top coat to the bottom, or to the primer, is based on how long the primer is allowed to cure or flash before you put the top coat on. So we did different time amounts to let that bottom coat cure. And we did 3 different tests at 3,000 PSI with a flat nozzle. We couldn't get any paint off. It wasn't until we beat it with a hammer in one spot we were able to get some paint off around that. Otherwise, all 3 tests passed with flying colors.
So
we couldn't get any paint
So
off.
that's a new
PSI.
paint process to you guys?
As 6 months ago, we had 2-part urethane paint.
We had some for the testing that we're doing here. We had similar issues. We just started doing it. Then we realized there's more to it than just putting on the primer and painting.
Yeah.
And we have to follow our right policies and procedures.
Yep.
We were just painting stuff as we used to because we painted stuff for 50 years here.
Yep.
So now we're documenting, okay, when we do this, it does better. So did we have challenges with paint? Yes.
Yep. We even
Are we
proved
doing
out,
better? Way better.
Yeah, and we even proved out then, even in some of the worst cases where we're painting too quick or we're letting it go way too long, we couldn't get the top coat off. So it's a little more forgiving than we thought it was based on the testing that we saw here. So we'll continue, we'll see if there's any other variants to the test. We did say there's some pressure washers that go up to 5,000 psi.
Yeah.
There's rotating nozzles.
Oh, the
in
turbo
there.
nozzle.
Turbo
Oh my
nozzles.
gosh.
That
Yeah.
thing, that stuff wrecks everything.
Yeah, those
it
are
doesn't
horrible.
matter.
So, but based on a flat nozzle at 3,000 psi, they work.
So for you ConForms paint haters, we're trying. We're working on it. And this is some of the stuff we're working on doing.
But again, just continual improvement. That's why
Yes,
I call it
that's
CI.
exactly.
Yeah, the turbo tip on the hot nozzle or on the hot wash mid-December is a bad combo.
The Bumblebee.
The Bumblebee, yeah.
A lot like how we heat treat our pipe. We heat it up and we quench it. Just the only difference is here, we clamp onto the pipe and we push it.
This is induction bending, is what we call
Induction
it?
bending.
Okay.
So once the pipe is in like I don't know, when it's red, when it's in more of a gooey state, we just apply pressure and we bend it.
So this should be for like sweep elbows, for high-rise, stuff like that?
Yeah, our 50/90/48 heat treated. Any of our heat treated like 5-inch elbows especially come off of this machine. Until you get down to like the 9-inch center line where you can't bend that tight of a center line in this machine. Yeah, so we just run electricity through the coil and induce electrical current in the pipe, and that's what you.
And then it's going to clamp on and do the actual bend?
Yeah, so that clamp would clamp on. He's finished the bend, so he's just running a tangent.
Oh,
He's
okay.
just running a straight tangent because this bend's already done.
Oh, okay, okay.
Yep, but that's how he made the bend, was by clamping on, and then it just, the machine fights itself and you pull the bend.
Wow.
And then we check the temperature on the in-stratos and the ex-stratos to make sure you're getting an even heat pattern from the inside to the outside of the bend.
So that ring around the pipe is just a magnetic coil that creates the heat?
Correct. Yeah, we just run current through it. There's a lot of companies out there that induction bend, but our sweet spot on our chemistry and how fast we do it, like there's so many behind the scenes things that go into 50 years of ConForms being in business to perfect the science behind it.
Yeah, I guess it'd be quite a learning curve through trial and error and field
Yes.
testing.
I can waste a little bit.
The other thing is, as Matt said earlier, it's about continuous product improvement. So if we find out that we're having a specific issue with something, we want to know, we check it, these guys work on it, we improve the process. Does that mean we got to have a different way to heat it, different way of whatever? We're constantly changing stuff. You know, we have different weld ends that we've used over the years. There's a lot of things that we've changed. And again, that's about continuous product improvement.
Well, they did things like boom elbows, like a twin wall boom elbow. Would they first bend it in this same apparatus, then they insert the liner?
No, so a boom elbow is a shell and a liner. The shell is just cold bend.
Oh, it is? Okay.
Yeah, sometimes they'll heat them up as they're bending them, but not, this heats it up to heat treat it and bend it at the same time. So that is heat treating it as it's bending it. With a boom elbow, you don't want to heat treat it. You just heat it up to pull a bend quick, and then you slide an abrasion resistant cast.
So this should be more like in a concrete pumping application. This is more like high-rise sweep elbows, things like that.
The 50/90/24, the 50/90/48, those are all done. Heat treated ones are all done here.
So the ones that aren't heat treated, do they just bend them?
Yeah, we have a cold bend machine.
Oh, and it will bend those cold. You just don't get the heat treat benefit.
You just don't get the heat treat benefit.
I see.
Correct.
Same chemistry, so we don't have to have multiple parts in stock. Just one gets heat treated, one does not.
Okay.
Correct. Yep.
Okay, here we go. Let's see the Tony weld. Let's see what we found.
Yeah, it looks good.
It looks good, does it?
The weld looks really good, right? You can see the penetration there. The only comment that James had is it totally removed the heat treat. So you can see the lighter gray right here to the darker gray.
Yes.
This would be the heat treat. This is the heat treat removed.
Heat treat removed with heat treat.
Yep.
So for this stuff, this is just for high-rise makeup pipe.
Yeah.
So generally, it's not
You're
in
using
there for
it
long.
a couple times,
couple
and then you're
times,
pulling
and
it
it's
out.
gone. So I
Gotcha.
don't believe we're doing any water quenching
Okay, yeah.
when making these.
Which makes sense, yeah.
And even to water quench properly, see a lot of people do it with just like a garden hose dribbling in there.
really?
It's not going to be proper.
Yeah.
Yeah, just basically assume the worst with it, right?
Gotcha, yep.
Okay, so the weld is really good. Heat treat effective, which we anticipated that.
Yep. Yeah, weld looks awesome.
Excellent. So yeah, for something like a high rise, we'll use it for, I don't know, maybe at the most.
Course.
Yeah, so the most it would ever see would be like 1,000 yards of concrete through it.
Yep.
Cool.
This looks awesome. So,
Okay.
all right. And then
So we passed.
He passed.
He passed.
Do you have any hockey pucks out where we can show hardness testing?
Yeah,
I mean,
we
have
can
some
throw one
here.
out. Yeah, so actually, yeah, these are all, this is all, let's see where we are in this, but
Are they? Is that what got all the holes in it?
Yep. So when we do harness tests, every single heat treated pipe that we heat treat here, we run through a micro hardness testing machine, and that's what this is. So it's all automated. We can set it up, and then it takes 7 rows of hits all along the wall thickness. You can see that, and then we map it out. I don't have a graph in front of me. I can go get one.
So we can't put this piece of metal, you know, inside the machine, and they're all funky shaped, and it could be radiuses.
Yeah.
So there's put in this little hockey puck.
Yep.
And can you see those little dots in there too?
Yep.
Okay.
That's hard.
Those are the dots for the hardness testing, where that machine presses down on it, and it checks to see how much pressure.
Yeah, it checks to see the like how wide the depth.
So it can see the radius in the pipe. So this is the outside and that's the inside.
Yep.
So it's going to be harder on the inside, and as we work towards the outside, it's going to get a little
softer.
softer.
Yeah.
Okay.
So what happens is, the machine makes an indent, and if it's a soft pipe, the indent goes down more, so the hole is bigger. So that's what's
Okay. And how often do you guys run these tests? Like every batch of pipe?
every heat we get in for heat treated pipe.
Oh, really?
Yep.
Okay.
Yep. So we get in a batch of pipe. If there's a couple different heats, we'll run one for each heat. We just want to confirm that the heat, the chemistry is good, and then that the machine is running well. So
We'll also test stuff at random just to check people's welds and how the welds are doing.
Yep.
So in Tony's instance, if we really had to worry about this, we can do the same testing in this area and actually say that the heat, you know, here, which we can tell has changed the metal color a little
could
bit
test
here.
for that, see how
we could
much.
test to see how much that hardness has been reduced.
Yep, so that's what that machine does. That's a macro tester. So it's the exact same thing as a micro hardness tester. It just uses a bigger indent.
Okay, and then also
we go around the ID of the pipe, and then we take the OD. And
okay.
see. We don't section a wall. So
I wonder how much that would affect. So if this was a 57 HRC hardness pipe, I wonder how much that would take it back down to like a 30 or something with that kind of heat.
It looks like it probably fully took the heat.
Fully removed the heat treat,
exactly.
which
So
is
I bet
pretty.
in the teens or
Without using water to quench, that's pretty much what you're gonna. That's what you're gonna get.
The same thing would happen with our shop. I bet.
Okay, if they weren't to quench it.
Exactly.
So it's not so much the process of the weld; it's the fact that it wasn't quenched.
Correct.
Okay.
This is our quarter wall heat treated, similar to what we just saw in Etchev. This is tricky. They were. Let's see if I can better one. You can't see it very well, but again, you have this is the ID, this is the OD, and as you saw in the other video, they have about 7 hits all along the profile of the wall. And what this is it averages those 7. So each dot is an average of each of those 7 hits, and then as you see, it goes. This is the ID, and this is the OD, and you can see very hard on the ID, tapers down to soft on the OD to help the pressure. So
So the red is the average of the hits.
exactly.
Oh, so it was right at like 57.
Yep, and these are this exactly
Which is
right
what they
at 57.
advertise.
Yep, and these are our bounds.
And you get to
that
the
we
outer,
expect.
you're just over 20.
Yep.
As we say, you know, it gets softer as you go, so we get that ductility and the durability of the pipe, because if we get it all super hard, it gets brittle.
It's funny, so you get a real drop off in around like
That's
the
when we
50%
talk
range of the pipe, and then it kind of
Accelerated wear.
levels off it, and not a great number.
Exactly.
So the first little bit is pretty good, and then whereas with a twin wall, you're gonna get.
Twin wall's gonna be 6 exactly. Twin wall's gonna be 60, 65 the
You
entire
really see the
way.
benefit of the twin wall when you look at the profiles like this, right?
Exactly.
You don't get that exponential wear towards the end of the life of the pipe.
Exactly.
Do you have one of the colored heat maps that show the weld?
Absolutely. So this is the exact same profile you saw on a weld, and this is where you see. I'm trying to open it up. This is where you see all this heat. This is where all the heat treat is, and you can see that this weld was most likely water quenched because you see no removal of the heat treat under the weld.
Oh. What are we looking for color-wise if it affected the heat treat there, Carl?
It would be blue. So the weld we saw before would have been all the same, this dark blue right
so
here.
if this was heat treated too, or went too much with the heat, this area would start to be affected in here underneath it.
Yep.
Okay.
Yep, it all
So
be
it would
blue.
change the darker blue color.
Yep, exactly. I would have to poke around treat from the welding process.
Oh yeah, this one, the blue has come all the way down and the heat treat's toast.
Yep, exactly.
Now because the heat treat has gone kind of under the flange and under the weld, does that buy it some life where it can wear a little bit further before it's too thin, or is that not something you relied upon?
So when you reach inside, you look inside there, and right underneath the weld, you can feel it's washed out there. This is what we see. All this heat's been introduced here, and it's damaged right underneath the weld. We call it the heat affected zone. So you'll hear us mention that a lot. Under the heat affected zone, the heat treat's gone. So like where your brother welded, that area underneath there, that's a heat affected zone. We welded too hot, the heat came down, damaged the heat treat. So, you know, it's gonna lower the life of that quarter wall pipe that's heat treated. But if it was twin wall, it definitely changed the hardness and probably brought the hardness down from the 65 that would start up, you know, and drop it down into, like Carl said, the low teens probably.
Okay.
So it's definitely going to wash out more. That's why we try to say, don't weld your own makeups.
I have a twin wall deck pipe right now in the 38 meter that was welded not at ConForms, and yes, towards the end it's dished right out, and it's the rest of the pipe is great, so it's probably exactly that.
Right. Okay. So when we see this underneath the weld, we call that the heat affected zone, and that's where we see that damage.
So that's the importance of controlling the heat.
Correct. And the welding procedures and stuff, and the quality.
This is the other end? Yeah. Oh, perfect.
Oh, we got the other end now too. The other end of Tony's
awesome.
weld.
Thank you.
Oh, we got right in front of the screen. That's awesome. Thanks, man.
Yep, James, similar thing where weld looks good. Just the heat treat's on.
Yeah, there was no water quench used on that one, so I guess it shows.
So it'll hold for what he's doing because it's a limited use pipe, but it's not going to last like a new pipe will.
Yeah, it's going to be premature wear in that area right below the weld.
Right, the heat affected zone.
Yep.
Yeah.
Perfect. Thanks, man.
Yep, no problem.
And we can clearly see the this color and the metal there.
Yeah, so this is where you'd see it on the map all blue, and then you'd see that level of
right. So our
orange, yellow.
Blue here is basically the lighter.
Yeah. Correct.
There it is.
That's not that weld.
And there was no change from the first one was the horizontal weld. This is the vertical weld. No change. It's the same.
Yep, they both look the exact
penetration
same.
Everything is still good on this.
Penetration, exactly. Yep.
So same.
Yep.
Interesting. Okay.
You want to take that home to your brother?
Can I take it home?
Go for it. Cheers.
Go through customs of this, try and explain what it is. I've got this brother. He really likes welding, and
he's crazy, and he'd like to really see this. It would make his day.
Yeah, it'd make a keychain.
And I'm actually going to put it in his Christmas stocking.
I actually would. I'd make this a keychain and put it in the stocking. That's great. Okay, no, I will take that. That's awesome. That's so cool to be able to see it like right up against the computer screen.
Go put it by your stuff.
It's a good visual. Sure. Awesome. Thanks again, man. That's great.
Absolutely.
Thank you, Carl.